Hello, mathematical literacy learners. Welcome to the other half of the requested video. Finally, now that I have my printer, I can respond faster. Okay, 1.2. After Mapucho had purchased the bakkie, she decided to paint the cargo bin loading box of her bakkie with the rubberizing paint. The spread rate of the paint is 0.25 meters squared per liter. The rubberizing paint is sold in 5-liter tins. Okay, now let's just think about it for a second there. So Mapucho purchased the bakkie. So if you're in 1.1, if you remember, she had a quotation to buy the bakkie and was adding some extras and all of that and invested money to see if her interest can pay for the bakkie. Now she bought the bakkie maybe secondhand and now she wants to paint it, right? So she decides to paint the cargo bin, which is the loading box. Now, a van, in fact, if you don't have a canopy, the top part, you'll find that it's more like a rectangular box, right? So inside has a rectangular box without the top. So if you have ever been inside those vans or looked inside those vans, you find that there is a length and a breadth, right? So, and then it's deep. Some people have turned it into a pool. Some people use it for picnics. So that hole in the bakkie at the back of the van with the carry part, the part where they put the stiners and they put the groceries there. That's the hole we're talking about there. They've even given us the example just in case we don't know. But this one is open. So now we're going to close it. Right? And so if you look here, it has a length and a breadth. In fact, this one is the shortest side and this one here is the longest side. So that's the box that we're talking about. So they made it into a nice little rectangular for us, but we just have to remember it's not as flat as this rectangular here. As you can see, there are little bumps making this surface a little bit bigger than this one, but they've made up for that. Okay, so let's come back to a sentence. So it says here that the spread rate is how far the paint can be like spread out when you're painting while it's being effective. So you're not spreading it too thin, you're not making it too thick, and it's covering that much space. So they say if you do it properly, 1 liter will paint 0.25 meters squared, the paint. And then on top, have you seen that a lot of bakkies are black on that part? So what's causing it black is a protective layer of paint, which is more like rubber. And that paint is like rubber, right? So they paint it and then they paint it with rubber paint. So they're saying now if you lose rubberizing, this is... the paint is sold in 5 liters. So the paint that she's going to use is has a spread rate of 1 liter per 0.25 square meters. For every 0.25 square meters, we're going to use 1 liter, and the rubberizing paint is sold in 5-liter tins. So a photograph of the cargo bin of a bakkie and a simplified model of the cargo bin with dimensions are given in Annexure A. Dimensions means measurement. We forget that sometimes. Okay, so they're talking about this here. So you don't move without coming and check. So as soon as I find out there's an annexure, I read my stuff with the annexure. So there is our photography of the cargo bin or the bakkie, and we have that little rectangular box there, and this is the part that's going to be painted, including this area because it's closed, and then making the box have 4 sides, and that's the 4 sides right there. This one, they just made it simple for us so that we can understand it's a first box like that. Okay, so we're going to start. Rubberizing paint is a special paint used to coat the surface of a cargo bin. So she's going to make sure, so because that place is going to carry things like wood, sometimes, fetching some wood, maybe buying a bunch of blocks, for finishing here and there, cement. So you want to protect it. You want to protect the surface, and we do that by painting it with a rubber paint that can absorb all that friction. Okay, use the information above to answer and Annexure A to answer the questions that follow. The cargo bin does not have a flat surface area, and therefore the surface area must be increased by 2% to accommodate the uneven surface area. So that's what they're talking about there. They're saying, even though the simplified bin looks flat, but if you look closer at this one, you will see that there are little bumps, and therefore this is going to take a little bit more paint than our simplified. So we're going to calculate using the simplified measurements, and then we're just going to increase to accommodate for the surface here. by 10%, and that's fine. All right, calculate how many liters of rubberized paint Mapocho needs to purchase in order to rubberize the cargo bin of her bakkie. So someone said to me, how do you know that you can't just say 5 liters, 10 liters? How do you know? And I said, when you're going to paint, the most important thing you know is the surface area, or the area of the space you want to paint. So we're going to paint this front part, the back part, which is this part, the front part inside, which is this part, the 2 inside parts as well, which is the left and the right. So we need to know the area of this part, the area of this part, the area of that part, the area of that part. Once we know the size of our space, we then go and read the material written on the paint. And then this one says, if you have 1 liter, you will paint this much space. This is a conversion factor, which says that 0.25 meters squared is equal to 1 liter, right? And then we can then use this to, well, this is what we know before it's given to us. So before we worry about the 5 liter tins, we first need to worry about our space, and then we're going to calculate our liters, and then we're going to find out how are we going to buy it. Okay, this question says, calculate how many liters of rubberized paint Mapocho needs to purchase in order to rubberize the cargo bin. So we cannot purchase the paint without knowing our area first. And lucky for us, they've given us the formula for surface area. All right, so the next step for us is to substitute. But first, before we substitute, let's note what are we calculating here, which is going to be the unknown. We are calculating the surface area. Therefore, we cannot substitute anything there. So our surface area will equal to the width. As I have checked already, I checked my units of measurements. They're all meters, meters, meters. So if one of them was centimeters, I would have to convert it to meters, right? We're going to say our width here is this one. Right, so our width is this one. That means this area, this space here, this is the width, right? The width, how wide the bakkie is, right, from there to there. And that's what we're substituting here. And so that's how wide it is. And then our length is this part here. So when we talk about width and length, we are talking about width and length. So remember, we're not painting the top part. We are not painting the top part. We are only painting the bottom part. We are only painting the bottom part. Oh, do I not have crayons? Okay, note to self, get crayons. So that's the area space that we are painting when we talk about width times length. So look at it, width times length, right? Okay, so that's the part there. So width here is 1,37, 1,374 meters times the length, which is 1,807 meters plus 2. So now we're only painting the floor because the bakkie only has the floor. It doesn't have the top part, right? So maybe, no, we don't. We're not going to paint any other part except for the floor. Okay. Then we go to the sides now. Okay. So there's 2 of each side, and that's this side and this side, and that's the front and the back, right? So we are going to paint that step by step. So 2 here means that's going to be 2 times. But first we need to substitute. So length times height. Now, which part is length times height? Let's talk about it. We have length. This is the length times the height. So that means now it's the side here. Like I said, a note to self, get crayons. So this is the space over here now that we are painting. We're painting the side, length times height. So this side and this side are the same size. And I really need crayons. I wonder if Koki pens will be faster. It was so easier to do it with Koki pens. I'm going to first try Koki pens. Okay, we did it. We did it. Yes. We painted that side now. This side and this side is the one that we're painting when we say length times height. It has a length and it also has a height. Okay. So we're going to say length times height, which is 1,807 meters. It will be accommodated. No, height, which is 1,374 meters plus. So this will be accommodated by these two. It will be multiplied by these two and it will give us two sides. Plus a width. Now, when we're talking about width, we're talking about these two babies here, the back and the front, right? So we're talking about these two, the back and the front. So this part here and this part here. And if you come to the back, that's the part with the lead, and that's the part over there. Right? Very good. 1,374 meters times height, which is 0,535 meters. Okay, the rest is just BODMAS. Following the rules over there, we are going to say surface area is still our unknown. We're going to find it when we get the total here. And it says, okay, let's look for our pluses and minus first, because that's the fence for the different houses. There's a plus, which means this house is the Ramaphosa house, and this is the Zuma house, right? But within the Zuma house, there are sub-houses, like this one over here and this one over here, right? So what we're going to do is we're going to multiply these two and find the answer, and then we're going to put a plus sign, and then we're going to come here and say there's still a 2 here, and then we're going to put the multiply, because open bracket means multiply as well as these two going together. So we're going to put a multiply, and then we're going to multiply these two out and get the answer, right? This is the Duduzane house plus the brother's house. Okay, yeah. And then we're going to say these two, remember, they go together, but we don't have to put that, but I'm just going to put it there because it will still have two answers. Okay, so let's go. Let's multiply. So we're going to multiply these two in the Zuma house and find out how many is everybody. 1.374 multiplied by 1.807. And that gives us 2,482,818. There's a plus there, and then there's a 2. And then there's a multiply, and I'm still going to calculate those two here. So let's see. 1.807 multiplied by 1.374, which is 2,482,881. Wait, why do I have length times width here? There's something wrong here. Height. Oh, I got the wrong height there. The height is 0,535 meters. See, I make a lot of mistakes, but I always try and check as I go. So the answer here will be, now I'm seeing the answers the same. I'm like, wait, but the things are not the same. Okay, 1.807 times 0.535. Yes, that will give us 0,966745 meters squared plus, so I'm going to write it here, plus the other one, which is 1.374 times 0,535, and that is 0,73509 meters squared. Okay, so what I'm going to do is I'm going to start over this here. Surface area is equal to, so that's 2482818 meters squared plus 0.966745 meters squared plus 0,73509 meters squared. And then we're going to say we still need to sort this house out. So this one is not yet affected. Meters squared plus 2. And then we're going to multiply. We're going to add these two together because they go together inside the bracket. Plus 0,966745. And that is 1,701835 meters squared. Okay, so now our surface area is equal to, so now we have these two, right? Because remember there's a plus sign there. Okay, so 2,482,818 meters squared plus 3,40367 meters squared. And then we're going to add these two. Now the Zuma house is sorted, the Ramaphosa house is sorted. Now when they're together, how many are they? And that's a plus 2,482,818, and then surface area is equal to 5,886488 meters squared. Before I move on, I feel like I'm done, but I never move on without checking what the question had asked. What if they had said round off and I didn't? Ooh, you see? They said that you must increase, right, 2%. So calculate how many liters of rubberized paint Maputo needs to purchase in order to rubberize the car. I didn't answer the question. The question was not calculate liters. Okay, now I just have the space. Now remember, if we go back, we said that if you have trying to find out how many liters you need to paint, you first need to know the size of your space, and that is called the area, right? So now we have the size of our space. We just need to follow one more instruction. We must increase the space by 2%. So what I'm going to do is I'm going to do it the grade 12 method, where I say 100%, and that is the space here, plus 2%, and that's the increase plus decrease minus is equal to 102%. And therefore, I'm going to say now my space, which is 5,886488 multiplied by 102%, and that gives us an increased space. So 5,886488 times 102%. So that's divided by 100, and our space now is 6,0042176 meters squared. Right, now our space is increased. Now, if you like, you can go and calculate the percentage of 2% and calculate how much space is 2%, right? It will tell you how many square meters from there, and then you come back and add it here. It's the same thing. You can add the percentages, you can add the spaces. It's the same thing. Okay, so now we're going to calculate the liters. So we're halfway there. Now that we know our space, we're going to calculate the liters. So how do we calculate the liters? They gave us something to use. And on the, see, very important to go back to your statement. So on the statement, it says 0.2 meters squared, the space, can be painted by 1 liter if painted correctly. So I know that 0.25 meters squared is painted by 1 liter. This I know. But now I have a problem. I don't know how many liters I need to paint, but I do know that I need to paint square meters. So I wrote square meters this side. So the square meters that I have, I'm going to write on this side as well. Right? But I do not know how many liters, and then I cross multiply. So to this times that, right? That's how this works. Okay, so that one times that one, and that one times that one. We'll say 0.25 meters squared times the unknown is equal to 6,0042117 meters squared times 1 liter. Now, how is it possible to know unknown? It's sitting with 0.25 and they are multiplying each other. In order for it to go away, I need to do the opposite. So the opposite of multiply is divide. So I'm going to divide by 0.25 meters squared this side, and boom, boom, gone. What I do this side, I have to come back and do on the other side. And now my unknown is equal to the answer that's going to come out of there. And that's 24.01687,104 liters. Now I know how many liters I need to buy. All right. Calculate the cost of applying 2 coats of rubberizing paint, excluding labor, if a 5-liter tin costs 549 rand, including VAT. So if we buy 1 5-liter, we're not going to be able to finish, right? So in order to answer this question, which says calculate the cost, we need to first know how many 5 liters we're going to buy. I love paper 2 questions. Oh, they are my favorite. Okay, so they're saying a 5-liter tin costs 549 rand. All right, so we're going to go to 1.2. I don't know where I got 4 point something. Okay, so they're saying the cost of 2 paints. Okay, so we have 24.01687104 liters. We need to say this space is going to be painted twice, and therefore that's how we're going to do it. And so they didn't say that the first paint must be increased. They didn't say anything like that. So we're just going to continue, and we are going to then say 24.01687104 times 2, and that gives us 48.03374,208 liters, right? So this is how much liters in total we need if we're going to paint twice. That's fine. But now we go there and they say, we don't sell 50 liters and 25 liters. You have to buy it in 5 liters. So what I'm going to do is I'm going to take my paint that I need and I'm going to divide it into 5 liters. So if I divide by 5 liters, I'm cutting this. So let's say this is the 48 square meters. I'm cutting it into 5 liters. So if 1 5 liter here, and I'm going to divide and try and find out how many 5 liters can I buy, right? So what I'm going to do in order to do this mathematically, I say 48.03374,208 divided by 5 liters, and I find the number of liters, the number of tins. So that's divided by 5, and that's 9,605 606 9,606 606 74,8416. Right, now I cannot buy a quarter or a third of or three quarters of a tin, so I'm going to buy 10 tins, right? So now I can just say 10 tins times 549 rands, and that's going to cost 549 rand times 10. That's a very expensive paint, 5,490 rand. It says, explain the significance of applying rubberized paint to the cargo bakkie being the bakkie. Now remember, a bakkie is carries loads, sometimes load that can damage the surface of the thing, which is metal. So what the rubberized paint will do is it will absorb all the friction from everything that's been thrown there, and it will protect the bakkie from everything that's been loaded there. Also, the inside of the bakkie is not protected from the elements because it doesn't have a cover. It's not inside. So the elements will affect it. So it will also protect it from rust and everything else. Okay, so it takes 20 minutes to apply a layer of rubberizing paint. There is a 4-hour waiting period before the second coat of rubberizing paint can be applied. In addition, a further drying time of 2 hours is required after the second coat has been applied. Determine with calculations at what time the bakkie would be ready if the workshop started rubberizing the cargo bin at 8:15. Now, they say it takes 20 minutes. Start there. 1. It takes 20 minutes to apply a layer of rubberizing coat. So it's 8:15 and then 20 minutes is added. So it starts counting. After 20 minutes, they're going to be done applying a layer of rubberized coat. 1 layer, the first layer. And then they are going to then, for 4 hours, the period of the second coat of the rubberized. For 4 hours, they're going to let it sit. And they're going to wait before applying. So another 4 hours goes by. And then they put on the second coat, which is another second, right? 20 minutes. And then in addition, a further drying time of 2 hours. And then now, no, this is 2. And then this is the third method, the time. And then we have this part here, which is number 4, which is another drying time. Okay. So we have 8:15. Is this the finish time or is this the start time? That's what you need to know. So this is the start time. Start, and then the time will go up. You have to decide whether it's the finish time or the start time, because then you might have to go back minusing. And then if it's the finish time, the start time, then you have to go forward and add. Okay, let's start painting the first coat. Like we're going to do, we're going to paint the first coat. Let's say it takes 20 minutes. So we're going to say plus 20 minutes. And that's going to be 5:3.8. Simple. At 8:35, they're going to be done with painting the first coat. So number 2 is they're going to wait for it to dry, right, for 4 hours. And then we're going to wait for 4 hours for it to dry. After 4 hours, we have 12. So at 12:35, they're going to be done. So here we are applying the first coat. Is done. And this is the first drying time. Now, We're going to then apply the second coat, and that's also going to take 20 minutes. That's plus 20 minutes, and then that will be 5 dot dot 12. So at 12:55 we'll be done painting. We just have to wait for it to dry. This is the second paint or layer or coat, right? Okay, now we're done painting, but we're not done waiting for, we cannot give the car away because it's not dried yet. So we're going to give it another 2 hours, as they say here. The fourth part is to give it another 2 hours. So that'll be plus 2 hours, and boom. This, you can actually answer it like that, or you can edit on your calculator. I do not like that thing of adding time on the scientific calculators. I like to do everything manually. So this is the second drying time. Voila! Finished! Isn't that wonderful? I get my 4 marks. 1, 2. Now, we are sure that because we need area to know the space we're going to paint this, we are sure that we're going to use this formula. Once you've determined what formula you're going to use, you need to then remember. First, write your formula down, and then note your unknown. Go to everything you're going to substitute and make sure that all the units of measurement, if it's centimeters, it must be all be in centimeters. If it's cubic meters, if it's meters squared, it must all be in meters. If it's going to be millimeters squared, it must all be in millimeters. There mustn't be 1 centimeter there, inches there. No, it must all be in the same unit of measurement. So I'm going to come here and then write my formula down. So this is the formula I'm going to use for 1.2.1. And therefore, I'm going to write my formula down. I'm not going to write there because the surface area formula is usually long. And I'm just going to copy it down. Where is it? Here it is. So I'm going to copy it down. Jesus. So it says surface area is equal to, and then I say width times length plus 2 length times height plus width times height. Okay, so that's the area, the formula that we're going to use. Had we not been given the area, the formula, I would have just calculated each side.